My name is Alberto Odor. I'm a professor in the Health Informatics program at UC Davis School of Medicine and the Betty Irene Moore School of Nursing. I teach graduate courses in Health Informatics and Statistics. Biomedicine and Health Informatics rely heavily on probabilities and statistical inferences. Research work in these fields requires knowledge of statistical methods and skills to use them. There are many good commercial statistical packages like SPSS, SAS, Stata, etc., but they are expensive and generally time-limited. R is a language and environment for statistical computing and graphics. Based on previous work from the University of Auckland, since 1997, R's growth has been directed by a core group of 25 researchers, including Duncan Temple Lang from the Statistics Department at UC Davis. The comprehensive R archive network, with mirrors around the world, contains close to 6,000 statistical packages and 120,000 functions developed by a dynamic base of users. Besides being free, R is considered the current standard for scientific and academic statistics and reproducible research. I will show you that in 15 minutes, anybody can have a full R environment installed and set up with a graphic user interface similar to that of commercial packages. In this unbiased demonstration, I will also show you that you can perform most statistical analysis in R pointing and clicking with a mouse. It is a common misconception that R is hard to use in Macintosh computers. To prove this wrong, I will do this demo using a Mac. Searching for R statistics gives us the link to the R project. CRAN takes us to the Downloads page where we select UC Berkeley Server. We then select the most current stable version for 64-bit Mac operating system and follow the usual prompts to install the program. We then search for RStudio, which is a file management system for R. Again, we select and install the 64-bit version for Mac OS. We now have desktop icons for both R and RStudio. Clicking on the R icon opens the console, which is where you interact with R using program code if you want. A simple operation, multiplying 2 by 2, shows that the program is working. Clicking on the RStudio icon opens a window with 4 sections. One of them is the R console, another one is a scripting window, and the other 2 are environment and file management windows. Don't worry, we won't use them all in this demo. If you are using a Mac with a recent operating system, one of the Lions or Yosemite, you will need to install the XQuartz Windows system. Again, it is as easy as searching for the Downloads page, clicking on the current version, and follow the installation prompts. We now open the R console again and type what can be the only line of code you will need, and this is to install R Commander, the graphic user interface. Again, we select USA California 1 mirror, which corresponds to UC Berkeley. The instruction to open R Commander can be automated so that it is executed when you click on the R icon. We now see the R Commander user interface. File and Edit submenus have commands used in many other programs both in Windows and Mac computers. The Data submenu allows us to create and edit data sources, including and importing SPSS, SAS, Excel, and other types of files. The Statistics submenu is the location of many procedures. You can see many of the commands are grayed out. They get active if the data in use is in a correct format for the corresponding analysis. The Graph submenu contains frequently used chart types. Other submenus show commands to diverse mathematical models, statistical distributions, and useful tools. The Help submenu has links to extensive support resources. Opening the R Commander webpage, we find a list of plugins which can be helpful. It has tools to analyze evidence-based studies, Kaplan-Meier plots, single sample studies, text mining tools, etc. As an example, we will install the evidence-based medicine plugin, open R Commander again, and go to the Tools submenu to add the plugins we want to use to the graphic user interface. We can do so. We end up with new submenus for evidence-based medicine, Kaplan-Meier plots, and a full text mining set for natural language processing studies. We can now run some tests. First, we open the contingency tables window and add some numbers to perform a chi-square test. We click on OK and immediately get the results. Chi-square value, degrees of freedom, and significance are easily found. We use data on standardized heights before and 1 year after treatment with growth hormone to perform a paired t-test. We select the before and after variables, click on OK, and get the results. We show the t-value, degrees of freedom, p-value, and its interpretation. Charting this data can be done by pointing and clicking with a mouse, but the simple command in the console is faster. We'll now compare two groups of asthmatic patients, one treated with a bronchodilator and the other one with a placebo. We compare the forced expiratory volumes. Data are imported from a text file. We first get some summary statistics for both groups and then run the comparison. Results show the t-value, degrees of freedom, p-value, 95% confidence intervals, and the means for each group. We then test for homogeneity of variances and plot the mean values plus the 95% confidence intervals. Next, we will do a linear regression analysis of 12 determinations of HbA1c and fasting blood glucose levels in diabetic subjects. Data come again from a text file. We select the dependent and independent variables and click OK. Results show the residuals, regression coefficients, R and R squared, F statistic, and p-value. We then plot the regression line based on least square analysis. Finally, with 2 clicks of the mouse, we get 4 different representations of the residuals. The final example is the survival analysis of 2 groups of stage 3 lymphoma-treated patients with different chemotherapy agents. We first load the survival plugin and import the data, which include the time to death or sensor status with a grouping variable for different treatments. Initially, we calculate and get the Kaplan-Meier plot for all patients. We then recode the treatment variable to use it as a grouping factor and get the Kaplan-Meier plots for both groups independently. We finally compare both curves with a log rank analysis, which shows that there is no difference between the 2 treatment modalities. I hope I was able to show you that working with R is as easy as working with any other statistical package. Students can easily learn how to install it and how to use R Commander as a graphic user interface. That leaves most of the teaching time for instructors to teach the important stuff: conceptualization of statistics, selection of tests to perform, and interpretation of the results. Please don't let your students assume that they don't need to know how to run their analysis because they will be working with a statistician. Most of the time, they won't have the statistician. Also, learning how to clean and format data for analysis, what tests to run this data with, and how to chart and interpret the results helps students to learn and like statistics. See you soon in another video.